Alright Swifters, this is our last coding example in the You Are Awesome series. Now we're going to complete our app in this video, and in the next video we'll show you how to add an app icon and put that app on your phone. Now in this video we're going to get a little boolish. We're going to work with boolean values. Specifically, we're going to create a two-state control called UISwitch, which is either on or off. We'll add a switch to our app so that we can stop the sound from playing. We'll see an unexpected crash in our app, and we'll discuss the importance of edge case testing. And we'll learn how to use and or, that's the double ampersand for and the double bar for or, for complex conditionals. Let's finish this app. Now our app sounds awesome. But sometimes you don't have your buds or your headphones, and you want to silence that boost. There should be a way to shut off the sound. Yay! Yay! Well, we can do that. We'll add a UISwitch control like you see here. It has two states, on and off. Hey, we got a variable that has two states too, remember? The bool! So this little guy is true when it's on, that's the default green that you see here, and it's false when it's off, that's when it turns gray. Now that you're gaining some solid Swift skills, we can issue the next few steps as a challenge. But before we do that, it's a good idea to make sure that you've done a commit plus a push before tackling a challenge, just in case something goes wrong and you want to revert back to your earlier work. So here's our challenge. Let's move the button to the right and also change any auto resizing so that the button will remain on the right regardless of the width or the height of the device. Let's add this label that says play sound on the left. Add a switch control just to the right of play sound. Make sure auto resizing sets these so that they remain on the left. Set up an action for the switch called play sound toggled. Set an outlet for the switch called play sound switch. And for an advanced bonus, we didn't mention how to tell if the switch is turned on or off, but can you use code completion to find an attribute of switch that will give you this value? Explore after dot notation and see if you can do it. And then, can you add code to the IB action to turn off a sound that is currently playing? Now, if you can't get these advanced pieces, that's okay. We'll explore and show all of this in just a bit. Well, why don't you pause, give it a shot, and then resume. So back in our app on the main storyboard, we can drag the button to the right margin, and then in the size inspector, add the right anchor line so that we should have the top and right outermost lines selected, and you can see that they're darker red. That'll keep the show message button at the right margin regardless of the size of the device the app runs on. Then click on the library, find a label, add it over on the left margin, that's on the opposite side of where the show message button is. Set the text of the label to play sound, colon. Now you can check the size inspector, but by default the auto resizing should be top and left, and that's exactly what we want. Then go back to the library, find a switch, and drag it over and position it just to the left of that play sound label. Then get into the assistant editor so that we can create the action in the outlet. So click on viewcontroller.swift, option click on main storyboard, control drag from the switch over to the bottom of our code, just above the closing curly. We'll add an action. We'll call this play sound toggled. For the type, select UISwitch, then click connect. And scroll to the top of our code where we can add our outlet. Why don't we control drag from the switch again just underneath the last IB outlet that we created. We'll name this outlet play sound switch. It is of type UISwitch, so that looks good. Click connect. Then we can close our main storyboard and we're ready to code. Now let's first see if we can find that property or attribute of the UISwitch that can tell us if it's on or off. Now we could type in the IB outlet name here like play sound switch, since we created an IB outlet for it, and notice code completion tells us that play sound switch is a UI switch. And there's no problem doing this, but I'll show you that we can actually go ahead and use the sender. You see, sender was added by Xcode up here when it created the IB action function, and look at the parameter up here for sender. It says that it's of type UISwitch, and if we start to type in sender down here between the curlies, we can see code completion confirms, yes, it is a UISwitch. So let's type in sender dot and then see what kind of attributes are available in the UISwitch, and right at the top we see that every UISwitch has an is-on property. There's a chance that you might have to scroll through to find is-on if you've never used it before, but this is what we want. Code completion says this is a boolean value that determines the on-off state of the switch. If is-on is true, then the switch is green and it looks switched on. If is-on is false, the switch is gray and it looks switched off. And now if you hunted around trying other names instead of isOn, you might have tried, for example, .value, and you see that that doesn't exist. But .isOn, the isOn property that exists for every UI switch, is exactly what we want. So press return to accept this. And then what do we want to do? Well, we want to check to see if the switch is on. But if we type down here if, and then I move sender.isOn and follow it with curlies, well, anything that I put between the curlies will execute if the play sound switch is on. But if the play sound switch is on, I want it to just go ahead and continue to play normally. What I really want to do is I want to check to see if the play sound switch is not on, if it's off. If this value is false, because if the isOn value is false, then I don't want to play my sound. If the switch is on, well, it already plays the sound properly, so I don't want to do anything in that case. I just care about the false case. Now to check to see if sender.isOn, meaning our switch.isOn property, is false, we could just say if sender.isOn equals false. Now there are actually several ways to check to see if a Boolean value is true or false. Let's open up a playground and try out some of these techniques. So we'll go up under File, New, Playground, select blank playground. Next, I'm going to save mine to the desktop. I'm going to call it Bool Party and click Create. Now I'm going to expand my window. I can get rid of the str var here. And we'll start out with a var isOn equal to true. And just up top, I'll put a print statement that says true conditions. This will just allow me to separate that from false conditions that I'll print just below this. And then below that, why don't we say if isOn equals true, and then we'll say open parentheses, print, oh, it's on, else we'll print all bets are off. Now I'll command enter to run, and I see it prints out true condition, oh, it's on, because I set isOn to true. And remember the tips, just in case Playground isn't responding, you can go up and change import UI kit to import Playground support. Then you can open up the inspectors over here on the right, make sure the file inspector is selected. That's the one that looks like a piece of paper. And down here under Playground settings, you can select Mac OS. Now if yours is working fine, you don't have to worry about it, but if you do run into some problems and your Playground isn't working, you can just set it up the way that I've showed you right here. Either way will work. Also, if Xcode just starts to hang on you, you can quit Xcode, restart it. Hopefully one of those steps will get things working for you. Sometimes it takes a little while for the REPL to run for the very first time, but remember these steps if you run into some problems. Now I'm going to highlight this first if line here, Command C to copy it, then I'm going to Command / to comment it out, and then I'm going to paste the very same line below it, but I'm going to modify it. I'm going to remove equals true, and if I Shift Enter at the end of all this code to run it, I'll get the same result I got before. How come? Well, isOn is either true or false, and remember the condition that if will evaluate is it looks to see if it's true, and if it is, it'll execute what's right after the curlies. So if isOn equals true is like saying if true equals true, but if we're just checking to see if something is true and we're looking at a Boolean value, all you need is the name of the bool value. You don't need the equals true. That's redundant. It's not going to harm anything, but you don't need it. So in this case, you can read the statement like this. If isOn is true, it'll execute what's in the first set of curlies, but if it's not true, in this case if it's false, we will skip the first set of curlies, go into the else condition, and execute what's in the second set of curlies. And now there's another way to write this too. If you Command / to comment this out, and then Command V to paste what was on the clipboard, and modify isOn equals true, and say if isOn is not equal to false, and not equal is exclamation point equals, that also checks to see if isOn is true. It's a weird way to write it. I wouldn't advise you to do this, but all three of these statements mean the same thing and give you the same result. And if I do a Shift Enter to rerun, the console flashes briefly to say it executed again, and I get the same thing. Now let's super quick test some false conditions right underneath this. I'll say print, open parens, and inside the double quotes, I'm going to say \n false conditions. \n doesn't print. It's actually together referred to as an escape character. It sends a signal to print to say, hey, put a blank line before this. It'll just separate my results so they're a little bit easier to read. Then below that, I'll say isOn equals false. So I've already declared isOn with a var up here, so I'm just going to reuse it but set it to false. And below that, I'll say if isOn equals false. Then I'll copy both of the curly clauses in my true test above, and I'll paste it into the false test below, but I'm going to swap the two printout lines so that the first line should print out that something is false, it'll print out all bets are off, and the else condition will print out oh, it's on. Now remember, the stuff that executes immediately after the if statement will execute only if the if statement is true. So we're checking to see if is on equals false. Now, if this Boolean condition is on equals false is a true statement, then we'll print out all bets are off because we have identified something that's false. It is true that is on is false. Otherwise, if it's not false, it must be true. So that will be the opposite of this, and that's why we print out, oh, it's on. Shift-Enter, down below, we see false conditions, all bets are off because we set is on to false. Now let's show two more ways to get the same result, testing to see if it's true that something is false. So we'll highlight this first line, if, through the open curly, copy it with Command-C, comment it out with Command/, paste this line just below the commented out line, and change this line to read, if is on is not equal to true. Then click at the end of the code and press Command-Return, and we'll get the same result. All bets are off, because is on is still false. Then comment out this latest if line, paste our line below it to modify it, and I'm going to put an exclamation point in front of is on directly before the lowercase I, and I'm going to delete the part that says equals true. So the exclamation point means not. So by saying not in front of a Boolean, you're essentially saying if it's not true. And if it's true that something is not true, that's what we do in an if statement. We evaluate if it's true, then that must mean that it's false. And so that if it's true that it's false, we'll execute what's in the first set of curlies. This should continue to print out all bets are off. And in fact, if we move our cursor to the end of our code, type Command-Return, we see all bets are off. So remember, exclamation point is the not operator. It just toggles whatever's true to false and whatever's false to true. So here's a quick recap, and hopefully this is useful for the new programmer. If we're testing a true value, it'll be true if our condition says equals true, if we say just the value name, or if we say not equal to false. And if we're testing to see if a value is false, it'll be true that it's false if the value equals false, the value is not equal to true, or if the value has a not or exclamation point in front of it, which also says it is not true. So back in our code, if we want to check to see if sender.isOn is false, we can write it this way, sender.isOn equals false. That will work. That's easy to read. And if the switch is not on, then what we want to do is I'll just put a comment in here, stop playing. Now we could also test the very same thing by saying is on not equal to true, which you probably won't see. That's a terrible way to write this, but you are likely to see it this way, and you want to make sure that you understand this. Not sender is on is a test to see if this is not true, and it's very common for programmers to write this, so we're going to leave this in right now. Make sure that you understand this is a test to see if something is not true. Now, this was part of our stretch to try to figure out, hey, could we tell the audio player to stop playing? Well, why don't we go up? Remember, we called our audio player, so I'm just going to copy the variable name here. I'm going to paste it down below, and let's see what we can find with dot notation if it looks like there's some kind of method that might stop things from playing. So if I type in .play, we used a .play before, I could check to see if it is playing, but what I want to do is stop playing. I wonder if there's a .stop, and sure enough there is! It says it stops the playback and undoes the setup needed for the playback. I'm not sure what the second part means, but stopping playback sounds good, so let's press return and see if this works. And I'll just clean up a bit by putting this comment right behind the stop statement. I'll build and run. Here it comes, moment of truth, let's show message! Oh, and setting our play sound switch to off stopped the sound from playing. Now the play sound is off. What happens if we click on show message? Oh man, it's not staying off. We've got to toggle it on and off to shut it off again. Programmer, can you fix this on your own? Why don't you do a pause and see? Here's a hint. Up here where you call the play sound button in our message button pressed is what you're going to have to deal with. Think for just a sec. I bet if you put that magnificent brain of yours to work, you will get it. Pause. Give it a shot. Let's see how you did. So just before we play the sound, we want to first check to see if the play sound switch is on. So we can say if, and while we used sender down below, remember we did create an IB outlet for the switch. We called it play sound switch. We can say .is on, open and close curlies, and then just put our play sound in between. This way, every time we click on that show message button, we're going to hit this line. It's going to check to see if the switch is on. If it is, it's just going to go ahead and do what's in the curlies, play in the sound. But if the switch is off, it's going to skip what's in the curlies and never play the sound. I'm going to stop the app that's running. I'm going to build and run and see if we fix the problem. Let's first click a couple of times to play with sounds. And then we can shut the sounds off, that's good. But if we click show message again, look at this, it's not playing the sound. What if we turn play sound back on again and click show message? And you should bask in all that adulation because you are outstanding! Now there is one condition in the way that our app is coded that could cause the app to crash. And I'd ask you to avoid clicking the is on switch to off right away after you start your app, and the reason is this will crash the code. Now, a case that occurs rarely but that causes problems is sometimes referred to as an edge case. But these can be really important because if somebody takes steps in your app that you haven't tried but that are possible and they crash your app, then your users are not going to be happy. So squashing edge cases means better App Store reviews and happier customers. Well, we'll look at our edge case. So if we stop our app, restart it again, and then before clicking show message, we first turn off the play sound switch, our app crashes. Yikes! Why is that? Well, the error says unexpectedly found nil while implicitly unwrapping an optional value. Well, the only value on this line is audio player, and we're trying to call the stop method on audio player. So audio player must be nil. And we can double check this if we go down to the console. When your code crashes, you usually get this LLDB prompt. So you can type in statements to interrogate the value of your code at crash time using LLDB, which is the low-level debugger. So we'll use the PO command to print output of the value, and after PO we'll put space audio player, press return, and it says nil. Nil means there's nothing in there, so we can't say stop on nothing. That would be sort of like issuing a command to a car saying stop the car when a car doesn't exist. Swift won't let you run commands on things that don't exist, so that's why we crashed. Now, it's good that this happened here because these crashes where you'll get an unexpected nil are very common even among seasoned programmers. So here's the problem. We first ran the app. We turned off play sound. Then we clicked on show message, and then we got the crash. And as we just said, that's because audio player is nil, so we can't do a stop on nil, which is nothing. If we look at the beginning of our code, when you declared your values, this set of values up here was both declared and initialized. We can tell they're initialized because they have equal signs after them. But we only declared but didn't initialize our audio player value, and this was the right thing to do. If we declared it and initialized it to an empty audio player right away, that would actually crash our code in many versions of iOS, including the current version when I record this. But now here's the thing that's unusual. If we played a sound, we were okay. We never crashed. How come? Well, if we take a look at our play sound function, this line here initializes a new AV audio player. See, it uses the type name AV audio player, and it follows it with parentheses. This says, go to the AV audio player factory using this blueprint and create a new AV audio player with his data. And then it puts that value into our audio player variable, moving it from being nil with nothing to one that actually has an AV audio player inside of it. Once we do this, our audio player will never be nil. So how do we solve this crash? Just make sure that we don't run audioplayer.stop if audio player is nil and has nothing inside it. Now to check to make sure that a value is not nil, we can just use an if statement like this. If audio player is not equal to nil with a set of curlies, and then we can put our stop statement in between these curlies. This way we first check to make sure that the switch is off, and then if it is off, we check to make sure that we have something inside of audio player. It's not nil. And then only if both of those things are true will we try to stop the audio player. But instead of creating this nested if statement with one statement inside of another, we can create one if statement that checks two things. If play sound is off and audio player doesn't equal nil. The way we do this is we create what's called a compound conditional using a logical and in Swift, we write the logical and with two ampersands. Now, once we put two ampersands after the first condition we're going to evaluate, then we can put the second condition after the two ampersands. Now, this one if statement will only be true if both this half of the logical and is true and this half is true. Now I'll cut out audioplayer.stop and I'll put it right underneath my if statement with a compound conditional. I can get rid of this interior nested if statement. I don't need that anymore. And the only way we'll execute audioplayer.stop is if both is on is false, meaning it's off, and audio player is not nil, meaning it has something inside of it. That's it. And if you're wondering, yes, there is a logical OR. Instead of two ampersands, the logical OR is written with two bar characters, one after the other, no spaces in between. And the bar character is one that you don't normally type. On the US keyboard, it's Shift \\. That's the character just above the return key. And this truth table shows the difference between logical and logical or. So logical ands only evaluate true if both sides are true. Logical ors will be true if both sides are true or if just one side, either side, is true. Now finally, if you find yourself writing more than 2 conditions in a complex conditional, definitely use parentheses. It makes things easier to read, and notice these 2 statements down here have different results. If you evaluate false and true in this set of parentheses first, it's going to return a false. And if we say false or true, then that's going to return the value true. Now over here, if we evaluate first true or true, well, that's true. And then if we try to compare false and true, then we would arrive at false. So parentheses are your friends with compound conditionals. So this means we are completely done with the You Are Awesome app. First, let's see. Have we avoided the crash? There is no crash. And let's try this. No sounds. How about sounds? And you deserve that. You are great. You are spectacular. You have the design skills of Johnny Ive. Well, maybe if you're not yet there, you are getting there because you are gaining app skills. Look at how much you've learned. How to work with images and sounds and arrays and variables and functions and conditionals and complex conditionals. So randomization, loops, so much more. Hope you're feeling like a programmer. Congratulations. Keep at it.